Okay, good afternoon to you all. I'll be giving a talk on Springshed rejuvenation methods, SoP on Springshed treatment measures. So this SoP will be discussing about the SoP on Springshed measures designed by Ministry of Jal Shakti, and also will be touching those SoP which Niti Aayog has prepared. Okay, so we have already understood the concept of Springshed, right? What is a Springshed? The difference between Springshed and watershed. So just to recap or brush up our knowledge, Springshed is an area of land where water is, an area of land which supplies water to a particular spring. That is called a Springshed. Now, in contrast to that, what is watershed? Watershed is a land surface that is draining the water to a common point. So, this is a watershed. It is from ridge to valley, and Springshed can be a combination of 2 to 3 watersheds or more than that watershed. So, this we have already discussed. Springshed and watershed. Before going into any Springshed study or Springshed intervention, it is very important to understand the difference between watershed and Springshed, because what happens in the field, usually we get confused with the difference between Springshed and watershed, and when we do intervention or when we do Springshed rejuvenation methods, we need to understand clearly what is Springshed and watershed. Now, Springshed management. So, Springshed management, we have already discussed a bit about this. It starts with comprehensive mapping and spring inventory. So, in the first step, we have to inventory the spring, and we have to do intensive mapping and keep a spring atlas. Then, next is after inventing those spring, next is the data monitoring system. Now we have, suppose we have identified and mapped several springs. Our next step is to monitor the data, quality monitoring, then the discharge monitoring, all those to understand the hydrogeological parameters of that spring we have to do. Thirdly, after collecting all those information, the third is the hydrological assessment and recharge area identification. Our previous lecture, we have already understood how to demarcate the recharge area using various methods like the catchment approach, the isotopic method or a combination method, hydrogeological methods. So that is the third point where hydrogeological assessment and recharge identification is done. So suppose we have already identified the recharge area. Now, what is the next step? The next step is Springshed implementation protocol. Now, for Springshed intervention protocol, there are certain steps. Like, suppose we have identified the recharge area, then what structures can be taken up to enhance the discharge or the quality of that spring. So, and last is suppose in the fourth step, we have already implemented, we have constructed structures, we have given all those, and then the last is the impact assessment. After all this, we'll have to assess if our interventions have been successful. So the last is the impact assessment. So for Springshed management, there are two eventualities. First is by ensuring soil degradation and providing safe water supply for domestic and drinking purpose. And also the challenge is most of the springs, they have the recharge area in one area and the discharge point in the other area. So those factors are also to be taken into consideration. We will come into those steps one by one. So for identification of recharge area, these are the 4 main components which we need to understand in that recharge area of that spring. We have, Madam has already explained in the previous lectures that it's important to understand the geology of the area. It is important to understand the hydrogeological parameters of that area. Then the third is the environmental isotopic and also the water chemistry. Now, when it comes to Springshed management, 2 important approaches there. The first is the people-centric approach, and the second is the scientific approach. So people-centric approach, like Madam has explained, people-centric approach, why is it important? Because it is important to involve the community. When it comes to Springshed management, community involvement is very important. Without community's involvement, it is very, though we have studied the Springshed and recharge area, without community's involvement, it is very difficult to go ahead with Springshed interventions. So community people-centric approach is very important. Why? Because usually, like I've explained, the spring points and the recharge area there may have a different geographical area. So that's when we need to involve the community. The people residing in the recharge area may not directly get the benefit of that spring. So we need to make them understand that through your community involvement or through your generosity, this spring can be rejuvenated. So the one is the Springshed approach. We can come up with a twin model. Like we can sign a memorandum of understanding where a fair compensation, where both the recharge area and the spring can be benefited. So the last one, if you see, scientific methods plus community participation is equal to effective rejuvenation. So this is why people-centric approach is important. Now, in people-centric approach, these are the core components. First is the Springshed conservation and use, water management and rainwater harvesting. Then also we need to encourage afforestation and reforestation. We need to reduce soil erosion through better land use, improve livestock, support eco-friendly farming, use clean energy, and involve communities. So if you go through all these points, this cannot be achieved without the participation of community. That's when the people-centric approach importance comes into play. Now I have said that there are two approaches. One is the people-centric approach and the scientific approach. So this is the scientific approach. In scientific approach, there are three main points. First is the planning, designing, and evaluation. So these three is important for sustainable water source management or Springshed management. Now in identification, like I've said earlier, there is steps for Springshed management. First is the identification and mapping of springs. Mofi Madam has already explained a bit about this. So first step is to identify and map the springs. So what happens when we identify and do the spring mapping? We can come up with a Springshed atlas, and then for this, field verification is very crucial. So during spring mapping, these are the factors to consider: the geology, hydrogeology of the area. We need to consider the slope of the area and the rainfall. Why slope? Also we have already understood, because when we plan to do interventions, slope should be taken into consideration, and also rainfall to understand the hydrogeological pattern. Now first step is the identification and mapping of springs. Now next is the measurement of spring discharge and quality. So after those springs are mapped, we need to regularly monitor the spring discharge and water quality. So when we do this, when we monitor the spring discharge and water quality, it will help us assess the aquifer capacity through the discharge. Suppose we are regularly monitoring the discharge for a period of 1 year and the quality, so we can understand that, okay, this aquifer or this spring has this much storage capacity. Through those hydrograph and all those which we have already discussed, we can understand the aquifer capacity and the recharge potential. Suppose if it's if the discharge is very low or if the discharge is very high, we can understand that, okay, this is having a good recharge potential or a bad recharge potential. So through regular monitoring, it will give us this information. Now the third is the mapping of the recharge area of the zone. We have already discussed this. We need to identify the recharge zone. Three approaches: the hydrogeological mapping, catchment approach, and the isotopic. We will identify the recharge zone of that area. Now last is the recharge intervention. Now recharge intervention can be based on geology and land use. Not all the springs that we have mapped or monitored will not be feasible, may not be feasible for recharge interventions. So After mapping and studying all this, we will identify which shed area or the recharge area is important for intervention. Then we will go forward with the intervention like construction of check dams or trenches, which we call it as a physical intervention, or plantation like the biological intervention. Then social intervention is also important, which is when the people-centric approach comes into play. We need to protect those recharge area so that there is no disturb in that land use, there is no quality quality deterioration. Then the goal for all this is to minimize human interference in that recharge area. So these are the recharge interventions which we can do: biological, physical and social. So all these three components are important too for recharge. Now we'll understand the best practices of Niti Aayog. So Niti Aayog has come up with some best practices of Springshed management. This best practice has been done through 61 expert interviews, 32 expert online surveys and 27 Spring community interactions. So based on this Niti Aayog overview, in Springshed management there are 6 components. So we will go into the stepwise one by one. So the first one, which is the component A, is we need to understand the community needs and willingness. We have already discussed about this community involvement. Then we need to assess the technical feasibility, and by doing this, the social and technical feasibility surveys can be done, and village water security plan using budget assessment can be done. So this is the first component. Assessment is the first component. Now coming into assessment B, which is the spring inventory. I've already discussed spring inventory. The best practices which Niti Aayog has given are the standard format or mobile app for inventory. So there is a mobile app which we can use for inventory. Then we can build and incentivize village level institutions, like we have discussed. We can pay them some amount where they can regularly monitor that spring. Then enumerations can be given. Use of remote sensing and GIS can be used. We all have access to remote sensing and GIS, so those tools can be used, and publicly accessible spring data repositories, we can come up with that. So this is the component B, spring inventory. The third is the data monitoring. The data monitoring, we need to monitor regularly monitoring the discharge and quality, and the best practices of this, by regularly doing this, long-term monitoring protocols can be, we can come up with long-term monitoring protocols and institutional data management systems. So this is the third component, which is the data monitoring. The next one, component D, is the community mobilization and capacity building. So this is a very important. Community mobilization can be done, like awareness programs can be done. Then we need to, these are the factors, 1, 2, 3, 4, 5, 6, 8. These 8 factors are very important for this: community awareness and mobilization, village level formation and capacity building, gender and social inclusion. Nowadays we are very, the ministry is also very much interested in those, giving importance in gender inclusion. Then para-hydrogeologists can be trained to monitor and map those areas. School and in schools and college curricula, those importance and can be taught. Science policy action network, operation maintenance, livelihood link, water management. So these are the best practices for in community mobilization and capacity building. So this is done to raise awareness on water security and to include local knowledge. When we speak of Springshed management, local knowledge, the local people, local knowledge and raising awareness is very important. The next is the hydrogeological assessment and recharge intervention. So for this, fine scan geological mapping for aquifer identification has to be done. Geological mapping, hydrogeological mapping, all those needs to be done. We need to understand the hydrogeology of the area, and by doing this, it will help propose suitable recharge solution. So the best practices for hydrogeological assessment are field-based mapping handbooks, guidelines on recharge measures. We can come up with the guidelines on recharge measures. Then use of hydrogeological and isotopic techniques, and fourth is the regular regional aquifer mapping with advanced tools. So these are the best practices in hydrogeological assessment and recharge interventions. The next one is the funding and convergence. Now after doing this comes the funding. Suppose we have you have come up with you have mapped the recharge area of the spring. Now you want to do Springshed intervention, Springshed management. Now, but where do we get the funding? So these are the fundings and convergence which can be done. We can use multiple funding sources like grants or the CSR, and we can combine with the existing government programs. So these funds can be used to come up with the recharge interventions. So the best practices of these are government program convergence can be done, community contribution can be done, payment for ecosystem service, and national Springshed mission with IHR focus. Now we will come into steps for Springshed development action plan. This may sound very repetitive. This PPT may sound very repetitive, but it's a combination of the SoP from Niti Aayog, from ministry. So it will all be correlated. So these are the steps for Springshed development. First is the resource mapping. So for this, these are the basic steps which you need to go for resource mapping. We need to go with the GPS coordinates. We need to first and foremost, where we go, when we go to the field, what we do, we put the coordinates. So this is the first step. Then we can conduct participatory field visit. Using GIS and remote sensing, we can create an Spring Atlas and upload all those map data in a database or a portal. So step one is the resource mapping. So we will go into stepwise. So this is the step one. And now step two is the baseline study. In baseline study comes the measurement of spring discharge, quality, and aquifer characteristics. We can also collect the socio-economic data like the population. We have done this. Sir has discussed vulnerability assessment. We need to assess. So how do we assess? First thing, we need to collect the data, the information. Without collection of information or data, we cannot assess the vulnerability of that spring. So this is the step two, baseline study, collection of various information like the population, how many people are dependent on that spring, whether that spring is existing for a long period of time or it has recently, that spring has recently come into that picture. And then the usage, is it used for drinking purpose, for domestic purpose, or for irrigation purpose? So the third is the monitor the seasonal variation, spring flow for that hydrograph behavior. We can do whether the spring is perennial, whether it's seasonal. So in baseline study, these steps can be taken up. Now step three is the Springshed development plan. This is a step three. In step three, a combination of scientific hydrogeology and community knowledge is required for planning. Then, after which we can map the aquifer recharge zone. For this, we need to understand the rock type. We need to understand the geological structures. For this, we need to go to the field. We need to do geological mapping. I guess we have all heard how geological mapping is done. We need to understand the orientation of the rocks. And then the third is the apply participatory rural appraisal to gather community insight on that spring. And lastly, we can create a hydrogeological layout of that to understand the recharge flow pattern and critical intervention areas. So this is the step 3. Now next is the step 4. We are using all the first 3 steps. Now we have mapped the recharge area. The fourth is the revival plan, how to revive that spring. So revive hilltop lakes to recharge aquifer by diverting seasonal streams into them using channel or pipes. We can use stored lake water to infiltrate the subsurface aquifer and improving the spring discharge downstream. Or we can record GPS coordinates and topographic features of nearby seasonal spring and streams for effective planning. So the step 4 is the revival plan. What steps can you do? This may not be the exact, when you go to the field, this may not be the exact practical thing when you go in your area. But these are the steps which you can follow for the Springshed development. So the step 4 is the revival plan. Now the 5th step is the hilltop forest recharge. Now when suppose you have already done this, now you want to do recharge structure. So you can construct trenches, ponds, percolation pits and check dams. You can give awareness or promote afforestation or horticulture to enhance the soil permeability. Forest vegetation can be done, and by doing this it will help a sustainable recharge of that aquifer. So the fifth is the hilltop forest recharge. Now in step 6 and 7 is the DPR to implementation. The fourth is the preparation of detailed project report post field study. After your field study, you can prepare your DPR. You can get it approved from the competent authority, and you can assure proper placement of recharge structure. The third point is very important. Even if you have prepared your preparing your DPR, you need to understand the where the proper placement of those recharge structures is to be done. Then the fourth is we can follow best practices. So these are the steps for Springshed rejuvenation action plan. Then step 8, you have already done this. Now you need to monitor and evaluate. So for this you need to monitor the spring discharge and water quality for at least, it is advised to do for a long period of time. Then focus on lean season data. What happens usually, spring usually most of the springs, I would say most of the springs have a direct effect of spring discharge on rainfall. So it is important to measure the spring discharge during lean period. So in Northeast, the lean period may be from March to May, or in some areas it also starts by January. Then we need to evaluate the socio-economic improvement post-intervention. Suppose you have already done intervention, so we need to evaluate whether your interventions or the structures or your whatever you have proposed and implemented, whether it has given any improvement. So by doing this, we can ensure the continuous feedback and documentation. So this is the spring inventory. What needs to be done? First is the basic inventory and mapping. So we have already discussed this, so I won't go into it. Then the Springshed treatment. This is an image. You can go through how Springshed, these trenches are constructed to revive or to increase the discharge of that area. See, demarcation of its recharge area. The area may not be near the vicinity. Springshed may be located here in the downstream. So they have constructed trenches here so that water can percolate down and then it will recharge that spring. Validation of recharge worthiness, vulnerability of anthropogenic activities, and finalization of Springshed treatment based on location, slope gradient. So these are the important factors to consider for Springshed treatment. This is why community involvement is important, how the community involvement is important. Now, these are the steps SoP on Springshed Springshed treatment. So first is the, if you see here, first is the identification and mapping of springs. That is the inventory. Now after this, if you look, we need, after the identification and mapping of spring, you need to assess whether that spring is, in that spring people dependency is high or if people dependency is low. Now if people dependency is high, if many people are dependent on that spring, then you need to assess if there is any alternate source of water available. Suppose those dependency is very high and only that is the only source of water in that particular village or that particular community. Then we need to see if it is vulnerable to damage or if it is not vulnerable to damage. If that particular spring is dependent, people dependency is high, if it is also the only source, and if it is vulnerable to damage, then immediate action needs to be taken. If you can just follow my cursor, okay? So I can just, because many blocks are there, so we'll just go into one by one. So immediate action on protection needs to be taken. Now, if the people dependency is high, if there is no alternate source of water is available except rainwater, then, however, if it is not vulnerable to damage, then no further action, only protection from external sources in the form of fencing and pavements can be done. Now, if people's dependency is high, however, there is no alternate source of water available, if that spring is the only source of water, then we need to see if that spring source, if the discharge is diminishing over a period of years. If it is, if the flow is diminishing over a period of year, we need to assess if it is a seasonal flow or perennial. If it dries up, then it is a seasonal flow. If it is seasonal, then immediate attention and full-fledged intervention needs to be done. However, if it is a perennial spring, then intervention springshed management it is required. So if the people dependency is high and there is no alternate source of water, and if the flow is constant or increasing over the years, which is a good sign, then we need to assess if it is vulnerable to damage. If it is vulnerable to damage, then immediate action. Though the flow is constant and it's increasing, if it is vulnerable to damage, that means automatically we need to give immediate attention to it. If it is not vulnerable to damage, then no action is required because the flow is also increasing over a period of time and it is not vulnerable to any damage. So this spring will not come under the category of springshed, though you have already, suppose you have already marked the recharge area. By doing this assessment, you know that we don't need to do any recharge intervention in this area. So this one. Now, after identification, if the people's dependency of that particular spring is low, if it is low, then we need to assess if it is vulnerable to demolition through construction of roads, through construction of buildings. If it is vulnerable to demolition, then if it is not vulnerable to demolition, then no action is required. If it is vulnerable to demolition, then protection from external sources in the form of fencing and pavement needs to be done. So this is a, I would say, a chart for spring identification and recharge springshed management and its intervention. What steps need to be taken and what type of spring or the recharge area needs to be taken up for springshed management and interventions. Now, after this, next is the springshed treatment. Now, suppose you want to go forward with the springshed treatment or a springshed intervention in that particular area. So this is the step. Now, springshed management or springshed treatment, you want to go forward with it. First, what do we do? We identify the recharge zone of that particular spring. One spring is here, and you want to go with the springshed treatment of that spring. So first, we have to identify the recharge area, recharge zone of that spring. Now, suppose, let's imagine that we have already identified the recharge zone. We need to assess the slope of that area. Suppose if the slope of the area is high, if the slope is if the gradient of that slope is greater than 20%, then we need to see if the slope is greater than 45, then intervention may be difficult because if a very steep slope, intervention may be difficult. However, it is greater than 20 but less than 45, we need to consider the rainfall of that area. If the rainfall intensity is very high, then even if you construct, it may just fall off like that. So we need to study the rainfall pattern of that area. If the rainfall is very high, if the rainfall is less, say suppose in that area, if the rainfall is less, that is less than 200 millimeter, stone barrier or slope can be constructed. If the rainfall is less than 1000 mm, outward stopping terrace can be constructed. If the rainfall is greater than 1000 mm, then we need to assess. Now here, see the rainfall is high. So now further we need to assess if it is highly permeable, if it is less permeable, or if it is a non-uniform slope. If it is highly permeable, then bench terraces can be constructed up to having a slope of area up to 33% slope. And if it is less permeable, then inward sloping bench terrace can be constructed. So this is for the high slope area. Now for gentle slope, which may make our job easier. So for gentle slope, if it is 0 to 5%, then farm ponds and contour trenches can be constructed. If the slope is 5 to 10% slope, then percolation tanks and contour bunds can be constructed. If the slope is between 10 to 15%, check dams and nala bunds or stagger trenches can be constructed. And if the slope is between 15 to 20%, gully plugs and stagger trenches can be constructed. So these are the different Springshed treatment measures or which can be taken up, and the constructions of different structures can be taken up for different type of area. Now these are some treatment methodology. First is the vegetative and soil moisture retention measures. If you see in the picture, this vegetative and soil some vegetation can be constructed to retain the soil of that this thing. So by doing this, we can reduce the surface runoff, we can increase the retention time, we can increase the water population and trap pollutants. We can also increase the soil infiltration, soil moisture retention, slope stabilization, and stops sheet erosion. So by vegetative and soil moisture retention measures, we can achieve these steps. There are two measures: vegetative measures and soil moisture measure. So in vegetative measures, we can go for contour cultivation, strip cropping, tillage practice, soil management practice, and supporting practice. For soil moisture measures, we can go for plantation of local shrubs or herbs. If you see in some areas, in landslide prone areas, people they do construction. For example, this also, they put some wires and then they erase the flow of that soil. So those can be done. Combination of those can be done, and we can plant shrubs and herbs. The second is the engineering measures. First is the vegetative measures, which is like sort of a natural measure. The second is the engineering measures. So these measures need to be implemented in flat or moderate slope. To be selected based on available land, its type, rainfall, slope, soil, etc. of that area. So we need to consider these factors to go forward with engineering measures. So for flat and gentle slope, farm ponds can be constructed, percolation ponds, check dams, gully plugs, and nala bunds can be constructed. For a moderate slope, trenching, terrace fill, contour bunding. So these are the images, some of the images. Farm ponds can be constructed, check dams, percolation ponds. So all these engineering measures, these engineering structures are to arrest the flow of that water and to recharge the groundwater. Now there are certain, by doing all this, we also need to keep in mind certain measures. So these are the precautions. Attention needs to be given, like slope, gradient, soil cover for selection on interventions. We've already discussed this. Engineering intervention should be avoided in landslide. So why landslide study is also important in Springshed, because even if we go ahead with Springshed reconstruction of trench, suppose if it is a landslide prone area, then there will be no positive result to it. So these interventions need to be understood. Then intervention should be avoided in high slope area. Then grazing and other anthropogenic activities must be avoided in those in your recharge area or your intervention area. Then deforestation and felling of trees should be avoided. New construction or shifting cultivation, use of pesticides and fertilizers in the area should be prohibited. What happens usually in northeast, in hilly areas, people practice shifting cultivation. We call it the Zoom cultivation, which also affects the recharge and spring of that area. So those needs to be discouraged. Then waste dumping and sanitary tanks should be avoided within the that upstream of that spring. Then quarrying of sand or rocks should be banned in that area, and management of all this intervention must be ensured for both for engineering and vegetative. So these are the precautions which needs to be taken for Springshed management. So I'll have two slides on do's of Springshed management and don'ts of Springshed management, one slide each. So the do's of Springshed management are geotagging and classification of springs, perennial or seasonal. Then map of the recharge zone using GIS or remote sensing tools. Maintain a web-enabled spring inventory. Conduct regular water quality and discharge check, and protect the recharge area from population and defecation. So these are the encouragements or the do's of Springshed management. Now in Springshed management, what we should avoid? We should avoid site with no forest or recharge potential. If the area, if the spring area, zone has no recharge potential, then we don't need to go ahead with the Springshed intervention. Then we should not dig trenches or terrace fields on the rocky slope. We should avoid recharge work without our baseline data. We cannot just go ahead with our recharge structures. We need to do a lot of study before going with our recharge work. Then we should don't concrete legs, it hampers infiltration, and skip water intensive plantation like pine in dry zones. So what happens in pine, they take up water, so we should skip water intensive plantation in that recharge area. So these are the don'ts of Springshed management. That's it. Thank you. So these are the basic steps like which you can follow based on your area of field or your area of the place where you want to take up intervention. It may differ, but these are the steps which you can follow for the outline. The baseline will be the same, but like the vulnerability assessment we have done, if you feel like your area is more vulnerable to spring discharge, or if your area is more vulnerable to climate change, you can put those plus minus. Yeah, there's, yeah. I'll just show you one if you have time. Let me see if I have that PPT. This NIH, they have developed an app, okay, a mobile app where you can, input your data in that spring. And for geological mapping, there's an app in our phone which we can easily download, that Piyeno app, no? Where you can measure the dip and strike of that. Yeah, Piyeno. Data, you have to identify your own data. Piyeno app is an app where you can use not to measure the dip and strike. You know that Brandon compass and all, you know. Just show, okay, wait. This. See, for field survey mapping, you can use your GPS. Then for water, for measuring the discharge, you can use that volumetric method. Then this is this app, no? Mobile app. You can use for inputting your data. Yeah, that's it, I think. Then flow measurement, that VNOCH, no? Automatic water level recorder. This one, it can be used for measuring the discharge. This is a rain gauge station, automatic water station. And no one has taken a class on this. Okay, but I think it's designed for these groundwater resources, that's why. But this topic no one has covered, no? Scientific techniques for Springshed mapping and management, no? No, okay. Maybe there's another training in October in Springshed, so in detail maybe they'll cover these topics. But these are some these things you can use, this app and all. Or manually, see, we can use manually with using the topo sheet and all. We can identify the area Cs. For example, this is the planning of survey. This is the topo sheet. This is your area of study. These are the spring points. So there are different methods and techniques. Okay. Thank you. you. Just give them a call. They've reached.